Picture this. You're scrolling through TikTok or Instagram, or maybe you're binge-watching cat videos, and suddenly, poof, your internet dies. No Wi-Fi, no GPS, not even enough bars to call your mom. Or imagine a massive explosion on the sun and in an instant, satellites go offline. Power grids collapse. And in the skies above, nature puts on one of its most breathtaking shows, the Northern Lights. This isn't science fiction, it's real. And it's one of the most awe-inspiring yet dangerous phenomena in our solar system. What happened? Aliens? Hackers? Nope. It was probably just the sun throwing a temper tantrum, also known as a solar flare. Welcome to Pro Pathways, where we make space science fun, even if it involves giant explosions that could ruin your Netflix binge. Today we're talking about solar flares, what they are, why they happen, and how they turn Earth into both a disaster zone and a light show. So what exactly is a solar flare? Think of it like the sun sneezing, but instead of bless you, it blasts out radiation across space faster than you can say photosphere. Solar flares are intense bursts of energy caused by twisted magnetic fields on the sun's surface. These fields get all tangled up because the sun rotates unevenly. It's basically the universe's version of bad hair day. When those tangled magnetic field lines snap back into place, boom! Energy explodes outward in the form of X-rays, gamma rays, and other fancy-sounding stuff. And here's the kicker. A single solar flare can release as much energy as billions of nuclear bombs. So yeah, the sun doesn't mess around when it gets mad. The different types of solar flares now, not all solar flares are equal. Scientists categorize them into 5 classes, A, B, C, M, and X, where X is the oh we're in trouble kind. The larger the number, the more powerful it is. An X10 flare? Yeah, that's 10 times stronger than an X1 flare, and it can cause some serious problems for us. To understand how these flares form, let's take a quick tour of the sun's anatomy. Imagine the sun as a 3-layer cake. The bottom layer is the photosphere, the part we see glowing brightly. Above that is the chromosphere, a bit cooler, and finally, there's the corona, the outermost layer, which is weirdly hotter than the surface itself. That's right, scientists are still scratching their heads over that one. Solar flares usually happen in the corona, where magnetic fields go haywire. Picture them like rubber bands stretched too far. They eventually snap, releasing tons of energy. Sometimes they're accompanied by coronal mass ejections, or CMEs, which are basically giant blobs of charged particles hurled into space. Think of it as the sun spitting cosmic loogies at us. When these solar fireworks reach Earth, things can get wild. First, they hit our magnetosphere, that invisible shield protecting us from cosmic chaos. Most of the time, it does a great job keeping us safe. But during big solar storms, it gets overwhelmed, and that's when trouble starts. For starters, GPS systems go wonky. Ever tried navigating without Google Maps? Yeah, good luck finding your way home. Solar flares can distort satellite navigation systems, causing inaccuracies of up to several miles. Airplanes, ships, and self-driving cars depend on these signals, so a powerful solar storm could lead to serious disruptions in transportation. One of the biggest threats from solar storms is their ability to overload power grids. In 1989, a solar storm caused a massive blackout in Quebec, Canada, shutting down power for 9 hours. If a superflare hit Earth today, entire countries could lose power for weeks or even months. In an age where we rely on the internet for everything, banking, communication, business, a powerful solar storm could damage undersea fiber optic cables, disrupting the internet on a global scale. Oh, and don't forget about astronauts. If they're outside Earth's protective bubble during a solar flare, they're basically sitting ducks for radiation exposure. Even pilots flying near the poles have to reroute to avoid getting zapped. So next time you complain about turbulence, remember, it could be worse. But hey, not everything about solar flares is doom and gloom. They also give us one of nature's most jaw-dropping spectacles, auroras. When charged particles from the sun collide with gases in Earth's atmosphere, they create dazzling light shows near the poles. Oxygen gives us greens and reds, while nitrogen adds blues and purples. It's like the universe decided to throw a rave, and everyone's invited. People travel thousands of miles just to see these lights dance across the sky. Some cultures even believed auroras were spirits playing games or guiding souls to the afterlife. Personally, I think they're proof that the universe has a sense of humor. It throws a tantrum, then apologizes with a light show. As cool as auroras are, solar flares remind us how vulnerable we are to space weather. With our reliance on technology growing every day, understanding solar activity is more important than ever. But what is current status, and where are we with solar activity today? We are currently in a phase of the solar cycle where activity levels vary. This constant vigilance helps us forecast potential solar events, providing early warnings that can help mitigate their impacts on our technological infrastructure. Recent data shows that while we have periods of relative calm, the sun still has the potential to unleash significant solar storms. Enter space weather forecasting. Agencies like NASA and NOAA monitor the sun 24/7 using tools like the Solar Dynamics Observatory and the Parker Solar Probe, which literally touches the sun's atmosphere. Talk about dedication. By predicting solar storms, we can prepare for disruptions and protect critical infrastructure. Who knows? Maybe someday we'll even harness solar energy directly from flares. Free electricity, anyone? Given the potentially severe impacts of solar flares, scientists and engineers are hard at work developing strategies to mitigate their effects. Here are some of the measures in place and those being developed for the future. Space weather forecasting. Improved satellite technology and computer modeling allow us to predict solar activity with increasing accuracy. Early warnings can help power companies and governments take preemptive measures to protect infrastructure. Hardened infrastructure. Upgrading power grids, satellites, and communication networks to better withstand electromagnetic disturbances is a priority. This includes designing systems with better shielding and more robust fail-safes. Emergency preparedness. Governments and organizations are developing emergency protocols to deal with potential disruptions caused by solar storms. This includes backup power systems, communication redundancies, and coordinated disaster response plans. Research and collaboration. International collaboration is key. Agencies like NASA, ESA, and NOAA work together, sharing data and insights to improve our collective understanding of solar phenomena and their terrestrial impacts. Okay, so we've established that solar flares are the sun's way of reminding us who's boss. But the good news? We're not completely helpless! Scientists, engineers, and even governments are actively working on ways to predict, prevent, and mitigate the impact of solar storms. Let's take a look at some of the strategies in place. How can we protect ourselves from solar flares? Advanced solar flare warning systems. First things first, early warning systems. NASA, NOAA, and the European Space Agency have dedicated satellites keeping an eye on the sun 24/7, because let's be honest, we don't trust it. Key satellites monitoring the sun. SOHO, Solar and Heliospheric Observatory, tracks sunspots and coronal mass ejections, CMEs. SDO, Solar Dynamics Observatory, studies solar flares and their impact. Parker Solar Probe, literally flying into the sun's corona to gather data. Talk about a dangerous job! DSCO VR, Deep Space Climate Observatory, monitors space weather and warns Earth of incoming solar storms. These satellites give us a heads up, sometimes a few minutes, sometimes up to 48 hours, before a solar storm hits. That may not seem like a lot, but it's enough time for power grids, airlines, and tech companies to activate their defenses. So, let's talk power grids, one of the most vulnerable systems during a solar storm. When a solar flare hits, it can send surges of electricity through power lines, overloading transformers and causing blackouts. But here's how we can prevent that. Grid hardening. Power companies are installing surge protectors and grounding systems to absorb excess energy before it damages equipment. Automatic shutdown mechanisms. Some power stations are developing systems that temporarily shut down critical components during extreme solar storms to prevent damage. Decentralized energy grids. The future of power may rely on smaller, localized grids powered by renewable energy like solar, wind, and batteries. So even if a solar storm hits, parts of the grid stay online. Protecting satellites and communications. Without satellites, we'd lose GPS, internet, and communication, so keeping them safe is a top priority. Engineers are working on multiple ways to protect our space messengers from the sun's tantrums. Radiation-resistant shielding. New materials and coatings are being developed to deflect or absorb harmful radiation, reducing damage. Backup satellites and redundancy networks. Companies like SpaceX are launching thousands of small satellites as part of the Starlink network, so if one fails, others pick up the slack. Software-based adaptation. Some satellites can switch frequencies or enter safe mode during solar storms, minimizing damage to onboard electronics. Emergency preparedness. What can you do? Okay, but what about us regular folks? If a massive solar storm like the Carrington Event happened today, it could knock out power for weeks or even months. Here's what you can do to prepare for the worst, just in case. Have an emergency kit. Stock up on non-perishable food, water, flashlights, and batteries. Because let's face it, we are useless without electricity. Get a backup power source. Solar-powered chargers, battery packs, or even portable solar panels can keep your devices alive when the grid is down. Cash is king. If digital banking systems go down, having physical cash could be a lifesaver. Learn offline navigation. Since GPS may not work, old-school maps and compasses might actually come in handy for the first time in decades. Could a solar flare ever destroy civilization? In 1859, the Carrington Event was the largest solar storm ever recorded, causing telegraph wires to catch fire and shocking operators. If an event of this magnitude happened today, experts estimate the damage could exceed $2 trillion and take years to recover from. The sun may be unpredictable, but one thing is certain: solar storms are part of our cosmic reality. The question is, when will the next big one hit? As much as we love space and all things cosmic, we can't ignore the fact that the sun is unpredictable. Scientists are already working on next-gen solutions that could one day protect us from the biggest solar storms. Artificial magnetosphere. Scientists are studying whether Earth-sized magnetic shields could be deployed in space to deflect harmful solar radiation, kind of like sunglasses for the planet. Lagrange point. Solar monitors. More satellites will be positioned at Lagrange points. Perfect stable locations in space where they can observe and predict solar storms with greater accuracy. Geomagnetic storm simulation labs. Research facilities are creating simulated solar storm conditions to test how different technologies respond and adapt. Solar flares may seem scary, but they're also a reminder of how connected we are to the cosmos. From disrupting tech to painting the skies, they shape our lives in ways both big and small. So next time you see the northern lights or lose your Wi-Fi signal, thank or blame the sun. And don't forget to check out more videos on pro pathways to explore the wonders of the universe. Until then, stay curious and maybe invest in a Faraday cage just in case.